Okay, so this question is from NCRT chapter 2. This is example number 2.2, and the chapter name is Electrostatic Potential and Capacitance. In the question, here it is, two charges 3 into 10 raised to the power minus 8 coulombs and minus 2 into 10 raised to the power minus 8 coulomb are located 15 centimeter apart. At what point on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. So in this question, they have asked us, they have actually given 2 point charges, and the magnitude of those point charges are given to us, which is 3 into 10 raised to the power 8 and minus 2 into 10 raised to the power minus 8 coulomb. And they have told us that it is located at 5 centimeter distance from each other. Okay, so let's discuss, and in a line we will have to find out where the electric potential is 0. So let's see. First of all, I'm going to draw a line. I'm going to write the magnitude of these charges in this line. Let's say this is the origin O and one charge is kept at this point. Okay, let's say at origin positive charge is kept over here. Okay, so positive charge is 3 into 10 raised to the power minus 8 coulombs. Okay, and after, at a distance of 15 centimeter, let's say the distance is from here to here. This is 15 centimeter. Another charge Q or minus Q is kept, which is, let's say this point is A, and the charge is minus 2 into 10 raised to the power minus 8 coulombs. Now we have to find at what point the electric potential is 0. So let's say, first of all, let's say that electric potential is 0 at this point, and let's name this point as P. Okay, now if I'm saying that electric potential is 0 at a line joining O and A, and the name of that point is P. Now if the whole distance OA is 15 centimeter, so I can take this distance OP distance as this distance from O to P, the distance O to P I'm going to take as X. I can do that. Let's assume that this distance is X centimeters. Now obviously this distance PA, it will be 15 minus X. Okay, and we can also take it like if O is the origin, so this whole line OA is lying on the positive x-axis. So if this is X, so this whole thing will be 15 minus X. So I'm just writing it as OP is equals to X centimeter and PA is equals to 15 minus X centimeters. As we already know that OA distance is 15 centimeter. Now let's start solving this question. If I said that at point P the potential is, let's say, potential at point P. So I'm going to denote potential with capital V, and I'll write it as potential at point P. It is equals to, we know the formula, it is 1 by 4 pi epsilon naught into Q divided by R, isn't it? So here, let's say the charge is here, this is the charge, and I'm going to consider this point. From this point, what will be the charge or what will be the potential? So I know that charge here is O, which is, I'm going to write it as 4 pi epsilon naught into 3 into 10 raised to power minus 8 divided by X. Fine. Okay, since this X is in centimeter, I can also change it into meters, or we can simply find the answer in centimeter itself. So I'm not going to change it right now. Okay. uh, so it is x centimeter. Let's say this is the first one. Now the second one, this is for the first charge. Now for the second charge, this one which is lying on right hand side of the p. Okay, so I'll just write down 1 upon 4 pi epsilon naught into minus 2 into 10 raised to the power minus 8 divided by, and this distance is PA, which is 15 minus x to the whole square. Okay. Oh, I'm so sorry. It is not whole square. It is simply 15 minus x. Now, this is the system of charges. This is for the system of charges. So, I'm going to write down Vp. Let Vp at P is equals to 0. Let's say at P it is 0. So what is going to happen? Let's solve. On the left hand side it will be 0, as potential at P is 0. This is constant. I'm going to take it as common, 4 pi epsilon naught, and inside the bracket we will get 3 into 10 raised to the power minus 8 divided by x, minus this minus sign will come out and it will be 2 into 10 raised to the power minus 8 divided by 15 minus x. So since this is a constant, this cannot be 0. Only this right hand side term will be 0. So I am putting it as 0. It will be 3 into 10 raised to the power minus 8 by x minus 2 into 10 raised to the power minus 8 divided by 15 minus x is equals to 0. On solving this, we can find out the value of x. It is a simple linear equation. So I'm going to solve it now, or I can solve it like this also. I'm just putting this in the right hand side. So this will be 3 into 10 raised to the power minus 8 divided by x is equals to 2 into 10 raised to the power minus 8 divided by 15 minus x. Cross multiplication, this will get cancelled out, and on the left hand side we will get 15 threes are, it will be 45 minus 3x is equals to 2x. On solving, it will be 45 is equals to 5x. This minus 3x will go on the right hand side and it will become positive 3x. So it will be x. So from this equation, which is very simple, we can find out the value of x, which is 45 by 5, and we already know that 45 divided by 5 is 9. Okay, and in the beginning I told you I'm not going to convert it, so it will be, I'm not converting the unit, so the unit of x will be centimeters. So x is equals to 9 centimeter. 9 centimeter from here, the potential will be 0. Now this is the first part of the question. Okay, the second part of the question says, let's assume that the point is lying somewhere over here. They have mentioned this. Take the potential at infinity to be 0. Let's say this is the infinity point. Okay, now I'm going to take this distance as x, this much distance. Let's say it is on the extended line of this OA. This point is lying on the extended line of OA. Then this will be x, and this distance OA will be x minus 15. Fine. So now let's solve that part. Okay, now let's say the point is at infinity. that OP point is at infinity. Now it is over here. So OP is x and OA, we already know how much is OA. OA is 15. Okay. Or let's say this distance A into AP, this will be, now how what will be this distance? This distance will be x minus 15, isn't it? Okay, so now again let's put these value in the formula, okay, which is V is the potential difference. I'm not going to write the formula again. So V potential difference is equals to the first charge 3 into 10 raised to the power minus 8 divided by 4 pi epsilon naught into x, which will be simply x only because the distance is from infinity. Now this distance we will have to see, this distance. Okay, plus again minus 2 into 10 raised to the power minus 8 divided by, here it will be this distance AP. So AP is x minus 15. Now again at infinity V is 0, which is potential is 0. And this I'm going to take common, 1 upon 4 pi epsilon naught into 10 into 10 raised to the power minus 8 will be taken common and it will be 0. Again we have got this equation. Okay, so on solving, this equation will be 3 upon x is equals to 2 upon x minus 15 and it will be 3x minus 45 is equals to 2x. So this will be x is equals to 45 centimeter. So now we have got 2 points where the potential will be 0, that is x is equals to 9 centimeter and x is equals to 45 centimeter. So at these 2 points the potential will be 0 for these two charges. Okay, thank you.